Hello everyone, this is Hating Tian. Let's learn another conic section hyperbola. If I have a double cones and I want to slice it, the cross section is hyperbola. Or later we will see the hyperbola is horizontally like this or vertical like this. Okay, let's learn more about the hyperbola. The definition. Hyperbola is a set of all points that the difference of the distance from two fixed points, foci, is constant. That means every point on our hyperbola, we connect the points with my first focus, my another focus, or these two fixed point. The difference, for example, this is d sub 1, this is d sub 2. The difference is a constant. For example, is 10. And then another point anywhere on our hyperbola, maybe another side, here and here, we find the distance. So this one is d3 and d4, and we find the difference between these two distance is also 10. So that's a constant number. Let's clear it. Let's learn some definitions or some concepts on this graph. First, let's use this color. So is vertices. We have two vertices, and then we have focus. We have two foci, and these vertices and the foci, they are all on this horizontal line, and we call this transverse axis. And then we have another line which is perpendicular to our transverse axis. We call it conjugate axis. And we have our co-vertices. We have two co-vertices here and here. So in the middle, it is the center of our hyperbola. Okay, another definition is asymptotes. For all of the hyperbola, we have two asymptotes. So we say asymptotes is the straight line here. Our parabola is approaching to the line. So we have our asymptotes here. Another asymptotes here. So our hyperbola goes through the vertices, the two vertices, and getting close to our asymptotes here, here, and this way, here and here. Okay, let's learn more about the hyperbola. The transverse axis of the hyperbola is a line segment connecting the vertices. Its length is 2a. So the length between two vertices, this point, the distance 2a. So from the center to the vertex, here is a. Conjugate axis of hyperbola is a line segment through the center, which is perpendicular to the transverse axis. The length is 2b. The distance between co-vertex, let's use different color, this color. This vertex, this correct vertex, the distance is 2b. So the half, or we say from the center to one co-vertex, is b. And then the foci are always located on the transverse axis. Okay, we have the foci, two foci here and here. Vertices are the endpoint of the transverse axis. The distance from the center to each focus is c. where c squared is equal to a squared plus b squared. So c is the biggest number among the ABC. C is greater than a, c is also greater than b. And so we say from one of our focus, so let's use this color, focus to the center, it is c. So c squared is equal to a squared plus b squared. And the last one, distance from the center to each vertex is a. So we talked about this. From the vertex to the center is a. Okay, let's move on. Let's erase this. So we have two graphs. The first one, we have our hyperbola is open to the left and the right. So open to the left and open to the right. And what is our transverse axis? Is the line here. That's the x-axis. And where is the center? At the origin, 0, 0. So our vertices and foci, they're all on our transverse axis, or here is the x-axis. And we go up B unit, we can find our vertices, and go down B unit, we can find our two vertices. So this shape of the hyperbola, we're having the equation here. So x minus h squared divided by a squared minus the difference from the hyperbola, and the ellipse is the sign here. The ellipse is both positive, but now we have negative sign here. Okay. All right. So a is under the positive perfect square. So if the x part is positive, so a must be under the x minus h squared. And then we can, if we have the h comma k, which is my center. So our center is h comma k. Based on the center h comma k, we can move to the right and left a unit. So move to the left, move to the right a unit, we can find our vertices. And move up and down B unit, we can find our co-vertices. And if we move to the left and right C unit, where we can find our foci. Okay, so what is the asymptotes? So asymptotes for this graph, center at 0 and 0, y is equal to b over a, and y is equal to negative b over ax. Okay, so b over a or negative b over a is the slope of our asymptotes. Okay, later we will talk about how to find the equation of the asymptotes. Another graph, we see our hyperbola is open up and down. So this one, the transverse axis. Okay, transverse axis goes through our hyperbola is the y-axis. It's the y-axis. That means my transverse axis is parallel to the y-axis. So y the squared. So let's see the formula here. So y minus k squared. This y part of perfect square is positive. So under this positive perfect square, we are having an a. Then minus x minus h squared divided by b squared is equal to 1. So center is h comma k. Why I'm saying h, I'm writing k. Okay, h comma k. H comma k. We must find our h from the x perfect square and find the k from the y perfect square. And then, so if we know that transverse axis is parallel to the y, so finding our vertices, we go up and down a unit. Find the foci, we go up and down C unit. Finding the co-vertices, we go to the left and right B unit. So we can find the important informations. And for the asymptotes, center at 0, 0. So it is y is equal to a over bx, and y is equal to negative a over bx. Okay, let's talk about the formula finding the asymptotes of the equation. So first we list the y part because this is a linear line. So linear line, let's separate the y and the x and find the slope. So y minus k, we can find our y minus k from the equation. Okay, so here is the y minus k. Here is y minus k. So use a y minus k. It is equal to plus or minus rise over run multiplied by x minus h. So x minus h can be found from the parentheses here. The hard part is rise over run, or we say that's the slope part. So for the first formula, the transverse axis is parallel to the x-axis. So this one, okay, the slope we have learned. If I find the slope of a linear line, we can find a starting point. One point we say is center. We go up B unit and then run A unit. This is rise over run. So we're having plus or minus B over A times x. So slope is plus or minus B over A. So let's do the conclusion. Okay, for the first formula, transverse axis parallel to the x-axis, the asymptotes, asymptotes is y minus k is equal to plus or minus B over A, which is the rise over run, and then times x minus h. And for the second formula, asymptotes is same thing, y minus k is equal to plus or minus A over B times x minus h. Example 1, find the center, foci, vertices, asymptotes, and the graph. Let's see, first one. So from this equation, I can find the center first. So the center is equal to h comma k. What is h? What is k? H is inside of the x perfect squared, and the k is inside of the y perfect squared. So let's memorize that. Let's review what is the formula. Okay, so if the y perfect square is positive, we're having y minus k squared over a squared, and minus x minus h squared over b squared is equal to 1. Okay, so the k, y minus k, here in the parentheses, in the equation we have y plus 3. That means my k is negative 3, and the h is positive 2. Yes, positive 2. Okay, so let's rewrite my h and k. So h is 2, k is negative 3. Next, I want to see my graph is open up and down, or to the left or to the right. Okay, my pen is back. So first I see, okay, y plus 3 squared, this perfect square, y perfect square is positive. Okay, so my graph, the transverse axis is parallel to the y-axis. So my graph is like this, my hyperbola. So in the middle is the center. So center is here. If we go up a unit, down a unit, I can find my 2 vertices. I keep go up and down C unit, I can find my foci. And then to the left, to the right, I can find my co-vertices. Okay, that means I need to find my A, B, and C. So the A is always under the positive perfect square. Now we have y plus 3 squared is positive. Oh, that means under it, that is my A squared. So A squared is equal to 4. And B squared is equal to 9. And then we can solve for the A. A is 2, B is 3. What is the C? C squared is equal to A squared plus B squared. So C squared is equal to 13. So the C is equal to square root of 13. A, B, C, they are all positive values. Now I can find my vertices, co-vertices, and then foci. Later we can also find the asymptotes. Okay, vertices. If I'm not moving to the xy plane, so we can use this color. So the vertices on my sketch is based on the center go up and down a unit. So go up and down, the x value didn't change. We can copy the x value from the center. It's 2. Based on the negative 3, what plus or minus A? A is 2. And for the co-vertices, so we move to the left, to the right, B unit. So they have the same y's value. Let's copy the negative 3 here. And then the 2 plus or minus B, which is 3. And then foci. 2 foci go up and down C unit. So go up and down, the x value didn't change. Then based on the y's value of the center, negative 3, let's plus or minus square root of 13 because C is square root of 13. And then we talked about asymptotes from the graph. We put all of the information on my graph. So first, let's find the center. 2, negative 3, 2, negative 3 here. Second, we can find our vertices. 2, so this one, negative 3 plus 2 is negative 1. And negative 3 minus 2 is negative 5. 1, 2, 3, 4, 5 is here, vertices. And then we can find our co-vertices is 5, negative 3. So let's find 1, 2, 3, 4, 5. 5, negative 3 here. And then 2 minus 3 is negative 1. So negative 1, 3, negative 3, sorry. All right, we have our vertices and the co-vertices. Let's construct a box. Okay, you don't have to do this, but this method can help us, to find the asymptotes. Let's make a rectangle, or we say make a box. So if we connect the vertices, so vertex of my box and the center. Okay, this is the asymptotes, 2 asymptotes. So the transverse axis is parallel to the y. Okay, so my graph must be like this. So let's use this. My hyperbola will getting very close to my 2 asymptotes and goes through the vertices. Okay, getting close to it, getting close to it. And here we're getting close to the asymptotes and goes through our vertices. I finish my graph. And here, what is the asymptotes? So for this graph, the asymptotes has a formula. y minus k is equal to plus or minus, we have a over b. And then times x minus h. You can also say, why did you have the a over b? Because we have learned that if I find a slope, a over b is a slope, we go up. So rise over run, we rise a unit. We got to the vertex, and then run 3 unit, which is my b's value. So rise over run, so that is a over b. And then we can replace the k, h comma k and a over b. So with the value. So y minus h, we don't have to find the h and the k. So we just copy this. We copy the first parentheses and the second parentheses from the equation. Make the things easier. Y plus 3 is equal to plus or minus a over b is 2 over 3 times x minus 2. We're done. We found everything, and we also graphed our image. Okay, let's see example 2. Find the center, foci, vertices, and asymptotes, and graph the hyperbola. So this one is a little bit difficult because it's not a standard form. I don't have a perfect squared, so I need to construct a perfect square for the x and for the y. Let's group the x together. We have 9x squared, then minus 54x, and then minus, so I want to leave a space here. We plus something. Then minus, we can group the y together, 25y squared minus 50y. And let's move the, okay, leave a space here. Plus something is equal to, move the 169 to another side with plus 169 both sides. I need to construct my third term. What is that? So let's factor out the GCF from the first part, the x perfect square part. Factor out the 9, we have x squared minus 6x, then plus what? Make a perfect square. We have learned we divided by 6 by 2, and 2 is 3, so 3 squared. We see 6 over 2, all of them squared. So we can also erase it. It is 3 squared. And then, so I need to factor out the GCF from rest of the term. So from the y part, we factor out negative 25. So minus 25, minus 25, and we have y left. Y squared plus, so use negative 25 divided by negative 25 is 1, positive 1. And then negative 50 divided by negative 25 is 2. So plus positive 2y. And then the third term is 2 divided by 2 and square it. It is 1. Okay, so what is about my another side is 164. Need to plus something. So use a 9 times this 9. So 81. And then this is minus 25 times 1. So we also need to minus 25 times 1. We make both sides balanced. Now we can construct our perfect square. 9 times x minus 3 squared, because this is minus 6x. And then minus 25 times y squared plus 2y plus 1. It is y plus 1, all of them squared. And how about my right-hand side? Do the addition and subtraction. We have 2 to 5. Okay, saving 2 to 5. Sometimes my pen is not working. 2 to 5. And now let's make a 1 on my right-hand side. Divided by 2 to 5, everybody. So we're having x minus 3 squared over what? So the cancellation between 9 and 2 to 5, I'm getting a 25 at the bottom. under the x perfect square. And then minus, okay, bottom, 25 and 2 to 5. Do the cancellation. I'm having 9 here at the bottom. And y plus 1 squared. And another side, it is 1. Now let's see which perfect square is positive. X. So my graph must have the shape like this, open to the left and to the right. And under the x perfect squared, it is a squared. So let's find the center first and then find the ABC and the first vertices, full size, asymptotes. So first, let's say the center is h comma k. So h is x minus 3. So h is 3. And k is negative 1 because we have parentheses y plus 1. Okay, so what is the ABC? So a squared is 25. So a is equal to 5. And b squared is equal to 9. B is equal to 3. How about c? C squared is equal to so 25, a squared plus 9. So what is that? Is 34. So c with square root of both sides, square root of 34. Now we have the ABC's value, and then we can make a beautiful sketch. So we say we have, this is my graph. So based on the center, move to the left, right, A unit. Move to the left and right, C unit. We move up and down, B unit. Find co-vertices. So let's put the vertices here. So go to the left and right. The vertices, these 2 points, they have the same value as my center. Same y's value. With my center and different x value. So let's copy the y's value and the 3 plus or minus a. So we found our vertices. And how about the co-vertices? Co-vertices go up and down. It has the same x value as my center. Let's put the 3 here. And then based on the negative 1, we plus or minus b, which is 3. And how about the full size? We have 2 full size is on the transverse axis, has the same y's value as my center. So let's copy the y's value, negative 1. And then based on the x value of the center, we plus or minus our c's value, which is square root of 34. And we will talking about the asymptotes later, because we can find it from our graph. First, let's find the center, 3, negative 1. 3, negative 1 is here. Second, the vertices, 3 plus, so based on this one, we can move to the left and right 5 unit. You can also do the computation between this. You can see positive 8 and negative 2. So you can find move to the left and right 5 unit. So we can find the point here. Move to the right 5 unit. 1, 2, 3, 4, 5. Okay, this is also positive 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, no mistake. And now let's find the co-vertices. 3 and go up B unit, which is, so based on our center, we go up and down 3 unit. 1, 2, 3. And then go down 1, 2, 3. Is a point here. You can also do the computation here and then find the value. Now what should I do? I can make a box. So make a box with the given information, or make a rectangle. Okay. So let's wait because the pen is not working. Okay. Come down. So connect the vertices here and here. This is my asymptotes and another asymptotes here and here. And what else? Oh, I need my graph, because my graph goes through the vertices and then get close to or approaches to the asymptotes. So graph goes through the vertices and then get close to the asymptotes. So let's list the asymptotes equation. So we always have the asymptotes equation, which is y minus k, and I don't have to write find the k. We just copy this and copy this. So y plus 1 is equal to b, a positive or negative, b over a multiplied by x minus 3. And then we plug in b and the a's value. You can also find it from here. You say find the slope. We can go from the center, go up 3 units, and go to the right, run. How many units? 1, 2, 3, 4, 5. 5 units. So that is 3 over 5. You can also find from the b over a, 3 over 5. So the asymptotes is y plus or minus 1. Plus 1. Is equal to plus or minus 3 over 5, all multiplied by x minus 3. Okay, we're done. Okay, number 3. Find the equation of the hyperbola with focus negative 2, 4. Center is 1, 4, and the vertex is 0, 4. Okay, let's graph this one on the xy plane. Okay, let's see. And then let's see this. First, let's put the information on the xy plane. So first, we can start to do the center. 1, 4. 1, 4. This is 1, this is 4. And the second, let's find the focus. Negative 2, 4. Okay, for example, this is negative 2. And then this is negative 2, 4. This is a focus. I can put F here. I can put C here, represent center. What else? Vertex is 0, 4. 0, 4. Okay. From this information, I have learned that my foci and center and my vertices, they are all on our transverse axis. So transverse axis, that means this is a transverse axis. So I must have my graph like this. So make a sketch. I don't know the exact graph. So let's make a sketch. Okay, I need to find the equation. And this one, transverse axis is parallel to the x. Oh, x perfect square is positive. X minus h squared over a squared minus y minus k squared over b squared is equal to 1. Let's find the a, b, and h and k. H and k, and they are given because center is 1, 4. How about a and b? So a can be found from here. The distance from vertex to the center, it is a. So I can say a is equal to, here is 1. So from 1 to 0, it is 1. Okay, so how about b? It doesn't say the b, but I have the given information, which is c. Because I have learned from the focus to the center, it is a c. So let's say c is equal to, let's see, is from negative 2 to 1. So from negative 2 to 1, the distance is 3. So c is equal to 3. And how about b? C squared is equal to a squared plus b squared. So b squared is equal to c squared minus a squared. It is equal to 9 minus 1 is 8. B squared is 8. So let's erase this. Okay, we have the h comma k. We also have the a and the b. A and the b squared. So in our formula or the equation, we don't have the a. We have a squared and b squared. Let's find a squared. A squared is 1. We plug in all of the information. We have the center, okay, and we have the a and b. So we put it in. So x minus 1 squared over a squared, which is 1, or 1 squared. And minus y minus 4 squared, all divided by b squared, which is 8, is equal to 1. Okay, we're done. Let's move on to see next example. Example 4. Find the equation of a hyperbola with the vertices at -4, 5 and -4, 1. Focus -4, -1. Let's put this information on the xy plane. So let's see this. First, let's find the vertices. -4, 5. So let's say this is -4, and then this is 5. So my first point is here. Second point is another vertices is -4, 1. So let's say 1 is here. Okay, this is my another vertices. And then focus. One focus is -4, -1. Let's say this is -1, this is +1. Okay, so focus and vertices, they must be on the transverse axis. That means this is my transverse axis. I don't have to write. Then we can make a sketch of our graph. So let's see. Okay, let's make a sketch. We must have my graph look like this. Go through the vertices and then go up and down because the transverse axis is parallel to the y-axis. And then we can find our equation. We must follow this. Y minus k squared over a squared is equal to x minus h squared over b squared is equal to 1. Here is minus, is not equal to, so don't write equal to here, it's minus. And we need to find the h comma k and a and b. So finding the h comma k, I can find a point. That is the point between my two vertices. Finding this red point, we can say the center is at x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. So x sub 1 is, it is the x value of this point. X sub 2 is the x value of this point. And the y sub 1, y sub 2, they are the y's value of these two vertices, y's value. So we can plug in the x value and the y's value in this formula. So we are having C is equal, C is the center, is a point. It is, on the top is -4 plus -4 divided by 2 is -4. And you can also tell from the image, it has the same x value. Okay, how about the y part? 5 plus 1, 6. 6 over 2, 3. So center is -4, 3. How about the a and the b? So a's value can be found from here. So the center, the y's value here is 3. Here is 5. So from 3 to 5, the distance is 2. So a is equal to 2. And what is the c's value? Or we say looking for the b, but b cannot be found. So we can measure that from the center to this focus. It is So it is 4. So we put the 4 here. And b squared is equal to c squared minus a squared. It is 16 minus 2. 16 minus 2 squared. 16 minus 4 is 12. So we have the h comma k. We have the a and b. We can put all of these in the formula. So it is y minus k, y minus 3 squared, all divided by a squared, which is 2 squared. And then we can put the 4 here. We don't have to say 2 squared. And then minus x minus h. What is h? Minus negative 4 with plus 4. Squared, all divided by b squared, which is 12, is equal to 1. So we are done. Let's see number 5. Find the equation of the hyperbola with the vertices negative 10, 2 and negative 2, 2, and the foci negative 11, 2 and negative 1, 2. Okay, we can put all of these information on my xy plane. So this is x-axis, and the vertices, they are negative 10, 2. So let's say this is negative 10. And then 2. Let's say this is 2. The next point is negative 2, comma positive 2. This is negative 2, and then positive 2. Okay, we see the two vertices, they are on the, so they are parallel. So line them up, they're parallel to the x-axis. So which formula or the equation I'm using? X minus h squared over a squared. X squared is positive. Minus y minus k squared, all divided by b squared, is equal to is equal to 1. We need to find the h comma k and a b's value. Okay, let's put all of the information on the graph. Next, foci, two foci, they are negative 11, positive 2, and then negative 1, 2. It's not that beautiful. This is negative 11. And then negative 1, 2. So negative 1, 2. So we can make a sketch. This is my hyperbola. Go through my vertices. And then open to the left and right. And also we have our two foci. We can use the red color to represent the foci. Okay, what is the center? So we use the formula. Center, it is the half of the sum of the x value here. So negative 10 plus negative 2 is negative 12. And then the half of the sum of the y's value, 2 plus 2, which is 4. So the center is not a beautiful 4. The center is negative 6, 2. And how about the ABC's value? Okay, so let's measure that from this point, negative 6 here. So from this point to this point, what is the distance? From negative 2 to negative 6, find the difference. Negative 2 minus negative 6, big number minus small number, I'm getting a positive 4. So that is my A's value. We can put the A here. A is equal to 4. And how about the B and the C? So from the graph, I can only find the C's value. So let's use this color. So from the center to one of my foci. So what is the distance? That is my C's value. So the C is equal to, I can use -6, that's a big number, minus -11. So the subtraction will make a +5. Okay, can you find b or b squared? B squared is equal to c squared minus a squared, which is 25, minus 16. So it is 9. So b squared is 9, b is 3. So let's erase this. We plug in the information in our equation. What do we have? X minus h is x plus 6 squared, all divided by a squared, which is 16. And then minus y minus k. So y minus, what is k? 2. So y minus 2 divided by 9. Y minus 2 squared divided by 9 is equal to 1. Okay, let's see. Next example. Write the equation for the hyperbola with center at origin. So origin means 0, 0. Vertices at 0, 5 and 0, -5, and foci at 0, 8 and 0, -8. So let's graph it first. Okay, center is at origin 0, 0. H, k is 0, 0. Vertices is 0, 5 and 0, -5. And what else? The foci 0, 8. This is 8. 0, -8. -8. So we can make a sketch. All right, which formula I'm using? The y positive one, because my transverse axis, this one is parallel to the y-axis, so y is positive. Okay, so y minus 0 squared, or I didn't put k and h information because I know that the origin, the h, k, they are all 0, 0. So the bottom is a squared minus x minus 0 squared, all divided by b squared is equal to 0. Let's identify our a and b. So a is the distance from here to here is 5. C is 8. So we can find the b. Okay, a is equal to 5. C is equal to 8. And the b or b squared is equal to c squared minus a squared. It is 64 minus 25. It is 39. Okay, let's move on. We have the a, we can find a squared, and we have b squared. We have the center 0, 0. So we plug them into the formula. Y, sorry, I don't have to have a parentheses. Y squared over 25 minus, so 25 is a squared, minus x squared over 39 is equal to 1. So we're done. Okay, let's see next example. Write the equation of the hyperbola. It gives us the center, length of vertical transverse axis is 4, and length of conjugate axis is 6. What is the meaning of transverse axis and the conjugate axis? For example, I don't know what is the shape of my hyperbola, but I can randomly draw my hyperbola. For example, the distance between the two vertices, so the distance from here to here is transverse axis. So it is transverse axis. Let's use TA to represent the transverse axis. So from the center to here is A, and double the A, that is the TA, or transverse axis. And what is the conjugate axis? So let's use different color. So conjugate axis is the distance from the co-vertices to so the distance between the two co-vertices. So here it is a conjugate axis. So we say CA, and the distance from here, okay, from the co-vertex to center, and from center to co-vertex is B. So 2B is CA, conjugate axis, length of conjugate axis, length of transverse axis. Okay, if we have this definition in our mind, we can move on and put all the information on my XY plane, and then start to graph it. Okay, first, the center is at -5, 2. So this is -5, and this is 2. So this is the center. And length of vertical transverse axis, that means 2A is equal to 4, because the length of transverse axis is 2A, distance between two vertices. A is equal to 2. And then length of conjugate axis is 2B. 2B is 6. B is equal to 3. Okay, based on the center. And then we don't know, we need to move up or down. Let's continue to see. Oh, here is the information, vertical transverse axis. Okay, that means my vertical transverse axis is parallel to the y-axis. So I must have my y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Okay, that means if I'm looking for the vertices, I just go up and down to find the vertices. And co-vertices, we go to the left and the right to find the co-vertices. So based on the center, let's go up. How many units? Okay, 2 units. And down 2 units, we can find our vertices. So go up 2 units. So go up 2 units. So this is 4. Okay, this is my vertices. And then from the center, go down 2 units. This is my another vertices. So we can make a sketch. So this is my graph. This question is not asking for the graph. It's asking for the equation. And what is the B? B is 3. So that means based on the center, we move to the right and left 3 units. So this is B, this is B. Oh, so this is co-vertices. Do I have to make a sketch and find more information? I don't think so. Because if we already had our center and we have the A's value and B's value, I don't have to find the graph. So I don't have to do this. We just plug in the h, k and AB's value in the equation. So y minus k minus 2 squared, all divided by a squared, which is 2 squared, 4. And then minus x minus h is x plus 5 squared, all divided by b squared. B is 3 squared, which is 9, is equal to 1. Okay, let's move on to see the graph, the function. Actually, we practice many graph of function. So let's do this one together. This one, it doesn't seem like the standard form, but we can add a 1 at the bottom. Then I can find what is A, what is B. So A squared is under the positive perfect squared. So 1 squared is A squared. Oh, sorry. 1 is A squared. So we identify what is my A. it is 1. Square root of the 1 is 1. And also we can find my b. b is square root of 9, which is 3. From here is b squared. And next, I didn't find my center. You can find your center first. You can also find center later. So center is h comma k. H is inside of the x perfect square, which is my 2, comma k is negative 3. And then we need a c's value. C squared is equal to a squared plus b squared. It is 10. You can also find the square root of c squared. So c is equal to square root of 10. We had a lot of information. We can find our vertices, co-vertices. Let's wait. It's saving. So co-vertices and the foci. What else? Asymptotes. So let's find the vertices first. So vertices. Okay, before that, let's decide the shape of our hyperbola. So the x minus 2 squared is positive. So my graph is parallel to my graph transverse axis is parallel to the x-axis. It's a horizontal line. Okay, that means I need to have my graph like this. So the transverse axis goes through this hyperbola like this. Okay, maybe we can put the sketch here. So first, let's find, we found our center. And then if we have the center, we move to the left, to the right, a unit, we can find the vertices. So vertices and the center, they have the same y's value. Let's copy the y, negative 3. And based on the 2 plus or minus 1, which is my a's value. And the co-vertices, that are the 2 points here and here. So they have the same x value as my center. So I can copy my x, which is 2. And then based on the negative 3, we plus or minus b. And then third, we find the foci. So first foci is here and here. That means we move our center to the left and the right C unit. They have center and the 2 foci. They have the same y's value. So let's copy the y's value. And based on the 2, we plus or minus square root of 10. Okay, let's have put all of the information on our graph. First, let's find the center. 2, comma, negative 3 is here. Second, let's find the vertices. So this one, we have the shape like this. So vertices, I'm going to the left and right a unit. So based on the 2, we plus or minus 1, we got these 2 points. These are my vertices. And the co-vertices is go up and down B unit. So we can also evaluate the value and then find the points. So go up 3 unit, go down 3 unit. So this is my co-vertices. So based on this, we can make a box. So connect 2 vertices, vertices. So this is my asymptotes, one of the asymptotes. So we need to connect the center and vertex, find another asymptotes. So let's make it symmetrically. All right, what is the other part? We can graph our function, hyperbola. So go through the vertices and getting close to the asymptotes here and here. Okay, I didn't put the C, foci, C's value. So based on the center, we move to the right and left C unit. So we can find our foci is, the x value is 2 plus or minus square root of 10. What is that? So based on the 2, we plus square root of 10 is about 3 point something. So for example, I put this, is that too far? 1, 2, 3. Okay, yes. So 1, 2, 3. Okay, so these are my 2 foci. What else? Asymptotes. Asymptotes, we copy the parentheses from our equation. So from the equation, so y plus 3, this is y squared, is equal to plus or minus. Let me ask you, is A over B or B over A? Some of you say, it's hard, I don't know. So rise over run. What is the rise? So based on the center, we go up 3 unit. So we go up 3 unit and then run 1 unit. Okay, we use 3 over 1. That is my B over A. Multiply by x minus 2. We plug in the AB's value. We're having y plus 3 is equal to positive or negative. B is equal to 3 and A is equal to 1. So it is 3 times x minus 2. You can also simplify the fraction. Y plus 3 is equal to 3, positive or negative 3 times x minus 2. Okay, that's the last question of 1.6. Bye-bye.